Unit 11 is going to take us into a little bit different branch of mathematics. We're going to be talking a lot about sequences and other patterns. So we're going to start with arithmetic sequences, which is really a fancy word for adding or subtracting. So all of these first sequences, we're going to be looking for a pattern in which we add or subtract. So in this long definition, the numbers 3, 4, 5, 6 represent the number of shingles in each row. That's an example of a sequence of numbers. So a sequence is a list of numbers in a particular order. Each number is called a term. So those are a couple important vocabulary. The first term is symbolized by A1, second one by A2. So a key concept here is the notation. A1 is the first term, A2 the second, A6 the sixth. So you can see we're going to end up with A to the nth is the nth term, some term somewhere out in the future. The graph here represents the sequence from the table above. It's a discrete function. Remember, discrete functions are unconnected dots. That means that right here at 1.5, there's no value. If we were connecting it as a line, that means there are infinite values between each point. Discretes, the only value at 1 is roughly 2.2. The only value at 2 is 4. There's nothing in these in-between places. So when we are looking for these sequences, we need to find the pattern. So the pattern is the common difference. Okay? And that is what we are going to add or subtract to make the sequence work. So you have to know what all of these variables, these notations mean. So when we get to our first example here, finding the next terms, if I give you a sequence like this, we need to figure out what happens between each piece. So to go from 55 to 49, I'm getting smaller, so I'm subtracting. How much am I subtracting? I'm subtracting 6. Does it work for each step? Yes. So that means that D is -6. In this situation, A1 is 55. Now if I want to find the next 4 terms, it's simply a matter of starting with 43, subtracting 6 to 37, subtract 6 to 31, subtract 6 to 25, subtract 6 to 19. So pretty simple stuff. Now, here's where it's going to get interesting because, of course, simple things like that don't always present themselves. So we want a formula to be able to find any term, because if I want the 20th term of a sequence, I want A20, I don't want to go through A1 to A20. I don't want to have to calculate 20 terms just to find my answer. I want to go straight there. So if you notice, we've got some key things. A to the nth, that's what we're going to want. This n here is the same n there. So in this case, if I'm looking for a to the 20th, that n in parentheses is going to be 20. A1 is our initial value, and D is our common difference. You can solve for any 3 values in this. So I can give you problems where you're finding for a to the nth. I can give you a problem where you're solving for a to the first term, or I can give you problems where you're solving for D. It's simply a matter of substitute the given information and solve with algebra. So you're going to need to use your algebra skills. So for this situation, let's look first at this graph right here. So 75 is our initial value. How do I get from 75 to 90,000? How do I get from 90,000 to 105,000? I'm going to add 15,000 at each level. So that means that that is D. Now, the question says, assume that the sequence continues. How much would it cost to rent for 12 months? So we're really after A12. Now, I don't want to go through the 5th month, 6th month, 7th month, so I'm going to go ahead and I'm going to use my formula, this one right here. Now, I know that that's 12, so that becomes 12. I know my initial value and I know my d. So now it's a matter of substituting in. A to the 12th is equal to 75,000. We said that was A1 plus 12. 12 is my N. And 15,000 was my D. Simplify. And it would cost $240,000 to rent it for 12 months. If you want to check it, you can check by finding month 5, 6, 7, 8, 9, 10, 11, 12. Now, when we want to write an equation for the nth term, we're given this series right here. So, what do I know? A to the first is 8. What happens at each step of my sequence? Well, D looks to be 9. Does that hold true everywhere? Yes. So then I have everything I need to substitute into this formula. So there's my 8, there's my 9, distributive property right here. Come up with this, combine like terms between the 8 and the negative 9, and this is my formula for finding the nth term of this arithmetic sequence. So I could find the 30th term now if I wanted without jumping through all of the middle terms. Another key concept in this is called the arithmetic means. And it's really a fancy word for saying the numbers between. Okay? Now, why this matters is it can help us figure out that common difference. So we can go ahead and figure out the equation, we can figure out the common difference. We can do a lot if we know, two numbers that are out of order, maybe the second and the fifth, the third and the seventh, and we can kind of work backwards. So, find the 4 arithmetic means between 16 and 19. So what do I have here? I really have, and I recommend drawing this concept. Draw that into your notes. Now here they're giving us the first term, which is 16, and what ends up being the 6th term of 91. So they're going to go ahead and use that 6th term and what they know, substitute everything in, and solve by, find for D. Solve for D, which is 15. And now you can go ahead and fill in your values by adding 15 to each level.